Hello everyone, today we will talk about the chemical factors affecting microbial growth. In our previous classes we discussed the physical factors that affect microbial growth and that the factor that we can use to do sterilization, disinfection or sanitizing. Today we will focus on the chemical factors. So first we can classify the chemical factors or the chemical method of sterilization depend on the physical state of the chemical we are using. So we classify them either as liquid sterilization or gas sterilization. In liquid sterilization, what we are doing is just submerging the equipment in the chemical fluid and let it sit there in the chemical reagent for a certain time. Depends on the microorganism and the tool we are trying to sterilize or disinfect. So there is a certain amount of time that we need to submerge our tools and equipment in order to make sure that we are killing all microorganisms and all spores. In gas sterilization, what we are doing is just exposing the equipment and the tools, or maybe the space, the room, the benches we are trying to sterilize, to the chemical gases. We also might use enclosed heat pressurized chambers, which means like we can use certain chamber like small oven or something where we can put the tools that we want to sterilize, and we can apply this gas chemical, spray our tools with it. In addition, we can apply some heat or pressure in order to improve the sterilization. So if you want to classify the chemical method based on the physical state of our material, we have, as I said, we have the liquid, alcohol, aldehyde, phenolic, halogens, heavy metal, surface active agent, and we could also have gas. In gas state, formaldehyde, ethylene oxide, and the rest. We're not going to take all of these, so just focus on the classes that I will explain in the following slide. So when we use the effect of chemicals on microorganisms, we have four terms that we have to understand and distinguish among them. So first we have sterilizant. It's not written here, so maybe you can add it to the slide. Sterilizant are the agent that are used to do sterilization. And in our previous classes, we defined sterilization as the process in which we do total destruction or total removal of all form of life on that surface or on that tool. Terminology that we use, or the other type of chemicals, we have disinfectant. So disinfectants are the chemical agents that are used to kill microorganisms, except for spores and viruses. So disinfectant do disinfection, they don't do sterilization because they are unable to kill spores and viruses. So we use disinfectant on inanimate objects, which means on instrument, and we don't use them on skin or mucous membrane. Antiseptics are very similar to disinfectants in which that they do destruction or inhibition of microorganisms, but the difference is that we can use them on living surfaces such as skin and mucous membrane. The fourth class of chemicals that have activity on different microorganisms are antibiotic and antivirals. So what's the difference between antibiotics and antiseptic? In general, antibiotics and antiviral are medication, which means they show their antibiotic or antiviral activity inside the body. So they work inside the body. We take them orally or IV to do that activity. Antiseptic only work on the surface, on the skin and the mucous membrane. They are not safe to be taken orally or as IV. So we don't call Dettol as antibiotic, even if Dettol can kill certain microorganisms, but we don't take it orally. It's not a medication, even if it has antibacterial activity. So Dettol is antiseptic. We use Dettol to a clean wound and stuff like that, but as I said, we don't take it orally, so it's antiseptic, not antibiotic. Antibiotic can be applied topically. We have many ointments or creams in which the active ingredients are antibiotic, so antibiotic can be used topically, but antiseptic, they cannot be taken orally or used inside the body. So that's the difference between antiseptic and antibiotic. Are different factors that can influence the activity of disinfectant and antiseptic. First, we have temperature. In general, increasing the temperature lead to the increase in the disinfectant or antiseptic activity. Higher temperature usually decrease the surface tension and the viscosity, and this will improve the activity of the disinfectant or antiseptic. However, very high temperature can lead to the degradation and loss of the activity because the chemical is not there anymore. So chlorine with higher temperature can be very corrosive and toxic. Iodine tends to sublime, which means it will transfer into the gas state at temperature 49 Celsius or above. The other factor is concentration. We can expect that increasing the concentration of the solution will improve the activity. Just remember that all of these chemicals, the disinfectant and the antiseptic, we use them as like in a solution form. We don't use them as a pure compound. We always mix them with water or something. So they are always come with certain concentration. So as I said, the higher the concentration means the higher or the better the activity. We also have the pH. In general, increasing the pH will improve the antimicrobial activity of some disinfectant like gutteraldehyde, quaternary ammonium compound, but it will decrease the antimicrobial activity of other compounds like phenolic compound, hypochlorite, and iodine. So this is because a change in pH can affect the ionization of the compound, and in general, we need the disinfectant or the chemical to stay neutral, not ionized, because we need the compound to pass the cell wall and the cell membrane of the bacterial cell in order to go inside the cell and do its activity. So ionization will prevent the compound from entering the cell, and this means we are losing the activity. The other factor is water hardness. Water hardness in Arabic, عسر المياه, which means water that has high concentration of cations in water. This will affect the solubility of different compounds. It also reduce the rate of killing of certain disinfectant because these cation can form ionic bond with the chemical, with the disinfectant or antiseptic, and sometimes this will lead to form insoluble complexes, and this will lead to loss of activity. Duration or like contact time or exposure time also will affect the activity. We can anticipate that the longer the contact time with the chemical, with the disinfectant or with the antiseptic will lead to more killing or more destruction of the different microorganisms comparing to short contact time. Age or how old is the disinfectant solution? As I said before, all of these chemicals are diluted with water. So older solutions means we are losing the effectiveness of this chemical, so it's better to prepare the solution fresh. Just prepare 60% or 70% ethanol just before you want to use it. If you have disinfectant or antiseptic at home, always make sure you are checking their expiry date state, because most of the time many chemicals lose their potency and activity with the passage of time and when they expose to air. Type of microorganism also will impact the effectiveness of the disinfectant and antiseptics. Not all microorganisms will be killed in the same way when we expose them to the same disinfectant or antiseptic. In general, endospore and biofilms are more difficult to be destroyed because these two types of living are designed so the bacteria can survive the harsh condition. We all know endospores from previous classes. Biofilms are when certain bacteria they excrete this extracellular material so they can surround themselves and protect themselves from other chemicals, and this will means they will survive different disinfectant and antiseptic. Number of microorganisms also play a role. In general, if we have a larger number of microorganisms on a certain surface, we can expect that we need a stronger disinfectant or higher concentration or more exposure time in order to kill all these microorganisms. Start with the liquid disinfectant or antiseptic. The first class is alcohol. In general, we use ethanol in concentration 80% volume by volume, or isopropyl alcohol 60 to 70% volume by volume. This is the usual concentration we use to disinfect the skin. I'm sure we all know this product that we use. Hand gels to disinfect the skin and the hand. Alcohol in general are effective against fungi, bacteria, and some lipid-containing viruses. Their principle or their mechanism of action is denaturation of proteins and dissolving the membrane lipid of microorganisms. Advantages: they are expensive, non-toxic, available, very effective, and they work against bacteria and viruses. Disadvantages: they are not effective against the spores, so we use them for disinfectant or antiseptic. We don't use them as a sterilizant. They are also not effective with organic material, which means they are not active if we have like blood spot or human fluid on the surface, so they won't be able to kill the microorganism in that blood spot. So in other words, in surgery room, they don't use alcohol to disinfect surfaces because alcohol is not effective with blood and other organic material. The second class is aldehyde. Like formaldehyde and glutaraldehyde, we use 2% solution of glutaraldehyde. So at this concentration, it will work as bactericidal, fungicidal, and virucidal in 10 minutes, and can be sporicidal in 3 to 10 hours. So which means we can use this chemical as disinfectant in short time, but if you want to make sure we are making a complete killing or destruction of all form of life, which means if we want to use it as a sterilizant, then we need a longer exposure times, like from 3 to 10 hours, to make sure we are killing everything, including the spores. Formaldehyde solution can be used in a liquid and in a gas state. It can be used for sterilization and disinfection of enclosed area. The mechanism of action is also working on a protein destruction of a protein and nucleic acid, mainly do alkylating. So proteins and nucleic acid lose activity because of this alkylating activity of these aldehyde. Advantage: they have good activity against the spore, viruses, and fungi. Disadvantage: They are toxic. They need long exposure time if you want to use them as a sterilizant. They're very sensitive, so they need to be fresh. They are very sensitive to any change in pH. They can be irritant and carcinogenic. That's why we don't use them as antiseptic. It might show moderate activity against tuberculosis. The group is the phenolic compound. These can be used as disinfectant, and a few members of this class can be used as antiseptic. In general, we use 5% aqueous solution. This should be enough to kill vegetative cells of different microorganisms, but spores won't be killed. So we use this, as we said, as a disinfectant, and the safe one can be used as antiseptic, but we don't use them as a sterilizant. If you are taking the lab this semester, I'm sure you will do this experiment, phenol coefficient experiment. Phenols are used as the standard chemical to which we compare the disinfectant and antiseptic activity. So we do in the lab, we do this experiment, certain experiment, and then we do some calculation to calculate the phenol coefficient. Then we can say this new antiseptic is 5 times more effective than phenols or less effective. So you will study this in the lab. The mechanism of action of phenol, they also work on destroying the plasma membrane and denaturation the proteins. The most known commercial product available in the market. This is the active ingredient. It's phenolic agent. As we said, some phenolic compounds are safe to be used as antiseptic. We can apply them on skin. We see them in soaps and scrubs, mouthwashes, and different other products. Another famous phenolic agent is triclosan, which was available in very different products, but in 2016 the FDA banned it from the market because of safety consideration. I'm not sure if it's still used or if we can find it in different products in Jordan. That would be nice if someone could investigate that. Advantages of phenol: they are stable, persistent for a long time after application, which means if we spray them on a surface or if we apply them on a surface, we can expect that after maybe 10 minutes or something, they still will be available on the surface and they will still be active. They will remain active after application. They also will be active in the presence of organic compound. So this was a disadvantage of alcohol, that they are not active in the presence of organic compound, which means we cannot use them in surgery. But this is not in the case with the phenolic. They're still active even in the presence of organic compound like blood or other body fluid. They are active against a wide range of organisms. They have antimicrobial activity, rapid antimicrobial activity. They are more active in acidic pH. And they remain active in surface long after application. Disadvantage: they're not effective at low temperature. This could be a problem for countries like in winter or countries with low temperature. They have cosmetic effect to the skin. They can cause systemic toxicity if they're used for a long time. They are not active against the spore, so we don't use them as a sterilizant, and they might have a bad odor. Halogen, mainly iodine and chlorine. Iodine is very famous and it's very common as an antiseptic agent. It has activity against different bacteria, fungi, and viruses. Everyone knows this product, the betadine. Mechanism of action is the same: inhibit the synthesis of a protein, cause oxidation of certain amino acid. In the market, we can find it in different preparation: 2% iodine plus sodium iodide diluted in alcohol, or as 7% iodine plus 5% potassium iodide in alcohol. Some preparation have 5% iodine plus 10% potassium iodide in aqueous solution. So we have both aqueous and alcoholic solution in different concentration. They are mainly used in topical application for skin or mucous membrane to prevent infection before surgery. Also, a famous preparation is the iodophore. This is the structure. Iodophore are special because they have iodine. That's why they have disinfectant or antiseptic activity, but also they are surface active agent. So they work as disinfectant because of they have two mechanisms of action, being a surface active agent and having iodine. Chlorine is also another halogen that has antibacterial activity. It's mainly used as a disinfectant. Clorox is the most famous brand name that has chlorinated compound. The active ingredient hypochlorous acid, HOCl, in aqueous solution. Some other compounds can be used like calcium hypochlorite, sodium hypochlorite. All of these are used as disinfectant. Chloramine are also chlorinated compound, but these are milder than the hypochlorous acid. That's why we can use them as antiseptic. We use this compound mainly for water pool, for swimming pool. So they are safe enough. You swim if the water get into your mouth or your nose, your eyes. It's safe enough. So this is what we use to disinfect swimming pools. Both iodine and chlorine work as oxidizing agent. They oxidize and inactivate proteins and amino acids. So this is their mechanism of action. Iodine compound, they are effective against gram-negative. They have residual activities, which means they stay active even after application. They retain microbial action even in the presence of organic material, blood or other body fluid. They can use in different formulation like spray, solution, and gel. The disadvantage, they can cause major irritation if they are used in high concentration or for very long time. They're weak against fungi and viruses, so we don't use them as a sterilizant. They might be absorbed into the skin and they can get to the blood and they can be toxic. They might cause first and second degree burns if they are used for a long time. The advantage of chlorinated compound, they are cheap and available. They're hardly soluble in water. That's why they leave a residual effect in the solution. They are toxic to different microorganisms and they can remove the taste and odor of other compounds that are soluble in water. Disadvantage, they are poisonous and toxic. They require careful handling and storage. The vapors of the chlorine can be irritant. They're strong oxidizing agents and they react with different elements, so we have to be careful when we store them. They also are very corrosive, and this means if we are using them, we want to pump them into the water pool, so we need to use different type of specific type of a tubing, like non-metal tubing, because as I said, they are corrosive, they dissolve metals. This is the heavy metal. In the market, we have different products that contain either mercury, silver, copper, or zinc. All of these heavy metal has germicidal activity. Mercury compounds can be, we use them in the liquid form as bactericidal. One of the most famous one are mercurochrome. We can find it in the market. These can be used as antiseptic because they're safe, not irritant, and not toxic. We can also find them as ointment. They use as antiseptic. Silver compound like silver nitrate, silver lactate, silver picrate, all of these are bactericidal. Silver nitrate is the safest one. That's why we can use it as antiseptic. Copper compound like copper sulfate have more activity against algae compared to bacteria, and we usually use them in concentration of 2 parts per million to prevent algae growth in fish tank. Zinc salt also control antibiotic, and they mainly active against anaerobic bacteria. The mechanism of action of heavy metal, they destroy cellular protein and inactivate them in different microorganisms. They are powerful biocide, but they can be very toxic to animals and the human. So we have to use them carefully. The sixth class is peroxygen antiseptic. These are safe enough, and that's why we use them as antiseptic to cleanse wound and disinfect the skin. We can also find them in mouthwash and other different products. Next class is surface active agent or surfactant. These are soaps and detergent. They have germicidal activity against different genera of microorganisms. They are ionized in water and they dissolve in cold and hard water. Examples of surfactants are the quaternary ammonium compound. These are ketogenic detergents that act as germicidal and bactericidal. They're very effective, mainly against gram-positive bacteria. They also have a fungicidal activity and can destroy different protozoa. Surfactants in general, in their chemical structure, they have hydrophilic part and hydrophobic part. That's why they are able to damage the cell membrane of different microorganisms. This is their mechanism of action. They also can denature protein, interfere with the glycolysis, and damage the membrane of microorganisms. Advantages of surfactant. They're very effective against vegetative bacteria. They are widely available, not expensive, they don't cause irritation. Disadvantage, they might be ineffective against spores, against viruses. They don't work well in hard water, and they might become contaminated. We mentioned quaternary ammonium compound as an example of a compound that are surfactant. Other name for them is quats. These are antiseptic. They're very famous. They're known to be disinfectant for the skin before surgery. We also can find them in like different adhesive bandages. They are the active ingredient here inside the bandages. As we said before, quats are surfactants, so they have polar part and non-polar part in their structure, and they mainly work on disturbing the phospholipid in the cell membrane. Next class is bisbigonides like chlorhexidine antiseptic. These can be used in oral and topical preparation. They are the active ingredient in mouthwashes, and we can find them in the market easily. Previous slides, we discussed the chemical agent that can be used for disinfectant, as disinfectant or antiseptic in the liquid state. And I think you should notice that all of them can be used as disinfectant or antiseptic. And I think there was one class, maybe the aldehyde, are the only class that can be used as a sterilizant. Now we will start with the chemical agent that can be used for sterilization when they are in the gas states. So this is very important because this is the primary way for sterilization. If you want to sterilize medical devices that are sensitive for heat, example like plastic syringes, certain plastic, petri dishes, etc. It's also the method of choice for sterilizing thermosensitive substance like hormone, protein, drugs, etc. The mechanism of action is a protein denaturation and DNA cross-linking. Disadvantage: the gas can be toxic for people, they are explosive, they could be poisonous or carcinogenic. We have two examples, formaldehyde and ethylene oxide. Formaldehyde is an alkylating agent. They are alkylate amino acid and sulfhydryl group of proteins, so they distract the proteins and the enzymes in the bacteria. They are strong, broad-spectrum disinfectant and biocide. They kill bacteria, viruses, fungi, and spores. That's why we are using it as sterilizant. It causes irritation. It's carcinogenic, so we don't use them as antiseptic. Ethylene oxide, they are also alkylating agent. They have good penetration. They can sterilize item within a plastic bag. So we can package syringes and inside bags and everything, and still this gas, the ethylene oxide, can penetrate the plastic bag till it reach, for example, the syringe. So this is considered an advantage, especially we are talking about like large scale production. Gas above 10 Celsius. Ethylene oxide has antimicrobial activity, also can kill spores, can be used in formulation with other gases like CO2. So this is just to show their mechanism of action and how they cause cross-linking on the DNA, different nucleotides. So this summarizes the mechanism of action of different class of chemicals, all the classes that we studied and the class. So this is a summary for their mechanism of action. As we said, most of them works either on proteins or the cell membrane. Yeah. So the slides from here till the end of the presentation are just a summary. I think everyone needs to take a look of them and study them by yourself. If you have any questions, just ask me in the class. Yeah, see you later. This is everything for today. Bye bye. You can take a look at all of these slides. It should be summary of everything we say. So if you have a question, just ask me in the class. And have a good day. Bye bye.